Hello, this is Mr. Henry, and welcome to lesson 4.1. We're starting a brand new module. It's going to be a huge module. It's 14 lessons. We split it up into two separate pieces. So we'll have a test after about module or lesson 4.7, and then from 4.8 through 4.14 will be the second half. So this module is essentially what algebra is all about. This module, we're going to talk about solving one-step equations, two-step equations, multi-step equations, equations with the variables on both sides. We'll eventually start talking about multivariate equations with two different variables, x's and y's, graphing them, solving systems of equations using a couple different methods. We'll even talk about things like proportions, cross products, constant rates, and how all of that stuff ties together. So this is a large chunk of what you will see on tests. That's algebra. This is algebra right here. This is getting you ready for the big time. All right. So it all starts here in this first lesson. This is lesson 4.1, solving one-step linear equations. And you should hopefully find this lesson to be fairly easy because most of you have done this a little bit in the past. The essential question says, how do I solve one-step linear equations? And so for our warm-up here, we have a type 1. So on the columns writing page in the front of your packet, 2 minutes on the timer, it says, write for 2 minutes about what you remember about solving equations. Do you remember some steps? Do you remember some rules, some formulas, some just little things here and there? So take 2 minutes, pause the video, answer the question. When you're ready, move on to the vocabulary, hit play, and move on together. We got some vocabulary. So the first one here is equations. And an equation is just a statement where the value of one side of the equal sign is the same as the other. So that equation I put up a second ago with the x plus 3 equals 10, this stuff is equal to that stuff. That's all an equation is. It's where you have this equal sign in the middle. A reciprocal, you might remember from even further down, or further back in time, would be the upside down form of a fraction. This is useful when you have a fraction in your equation. You want to get rid of that fraction. But reciprocal, so if we have like 3/4, the reciprocal would be 4/3. You kind of flip it upside down. So the numerator goes to the denominator, and the denominator goes to the numerator. Now this works, just some background knowledge, with whole numbers. So like, for example, the reciprocal of 5, well, 5 as a fraction would be 5/1. So the reciprocal would be 1/5. Now, still not quite getting to solving equations yet, but this example too. What we're going to do here is we're going to check to see if some numbers are a solution to the equation given. And I have here at the top in the title, this is very useful with multiple choice questions. And actually, most multiple choice questions on like PSSAs and that kind of stuff, you don't actually have to solve an equation for the most part. Because when they give you a set of choices, a lot of times what you can do is just check the choices to see if those choices are a solution to the equation. So a big, huge, ugly equation might take you 5 minutes to solve, but it might only take you 1 minute to plug some values in to see if those numbers are solutions. For example, this first one. Now we want to check each of these, 2, 5, 8, and 10. So if I plug in a 2, 4 times 2 equals 20. And I would check the math. Well, 4 times 2 is 8. Does 8 equal 20? The answer is no. So 2 did not work. So 5, 8, 10. Okay, and I'm going to try the next number. So the next number here would be 5. So 4 times 5 equals 20. Well, 4 times 5 is 20, so yes, 20 equals 20. That one worked. And for sake of completeness, I'm still going to try 8 and 10, but typically what you're going to find in most equations is there's only going to be one solution. So 8. 4 times 8. 4 times 8 is equal to 32. 32 equals 20 is no. And some in the math head. 4 times 10 will be 40, and so no. So for this equation, if this was like a multiple choice question, it says, your choices are either A, B, C, or D, this might be quicker for you than actually solving the equation. Now, this particular equation is pretty small, pretty simple, pretty easy, but imagine a 5-step equation or a 6-step equation. This might be simpler. Letter B. I'm going to use the same set over here. So, letter B. I'm going to plug in 2. 2 plus 3 equals 13. No. Try 5. 5 plus 3 equals 13. No. What about 8? 8 plus 3 equals 13. No. Must be 10, hopefully. 10 plus 3 equals 13. Yes. So, we've already done 2 questions, solved 2 problems without even solving an equation. We're just checking solutions. Now, I'd like you to do the same thing. You're going to check all 4 numbers, 2, 5, 8, and 10, for these next 2 problems. Check to see if these numbers are solutions to these equations. Go ahead, pause the video, do it on your own right now. When you're ready to continue, hit play, and we'll go through it together. All right, 2, 5, 8, and 10. Here we go. If we plug in a 2, 2 divided by 2 is not 4. If we plug in a 5, 5 divided by 2 is not 4. If we plug in an 8, 8 divided by 2 is 4. 8 was the solution to letter C. And for sake of show, if we plug in a 10, 10 divided by 2 is not 4. Okay, letter D here. Let's see, negative 3 plus 2 equals 5. Negative 3 plus 2 is negative 1, so no, that doesn't work. Negative 3 plus 5 equals 5. Negative 3 plus 5 is 2, so that doesn't work. Negative 3 plus 8 equals 5. Negative 3 plus 8 is positive 5, so yes, that worked. And finally, the 10. Negative 3 plus 10 gives us a positive 7. No, that one didn't work. So this is how you check the solution. So it works for these simple little itty-bitty equations. It works for wicked hard equations later on. Now, let's finally actually start solving some equations. So when you solve an equation, our goal is to get the variable by itself. We want to find out what that number is. Now, let me start by saying you could probably do most of these in your head. They're pretty simple, but I don't want you to do them in your head, because what's going to happen is if you get into the habit of doing all the equations in your head, or just thinking about it mentally, going, oh, well, 8 plus what equals 5, and thinking about it a little bit, that's awesome that you can do that, but it won't help you when you get to 3, 4, 5-step equations. There's actually a nice systematic way to do these problems, step by step by step. So here's how it works. In this letter A, I would probably start by separating the 2 sides of my equation. Write down this equal sign, make a line, because we want this stuff to equal this stuff. We want our equation to be balanced. So on the left side of the equation, my goal in the end, I want to have y equals and then some number. Because if I can get the y to equal say, make a number 5, play pretend. If I have y equals 5, that means that that number 5 should be the answer to the equation. It should be what the variable is, the missing number. To get there, we're going to do the opposite of what's happening to the variable. So my variable here is being added by 8. There's a positive 8 plus y. Well, to make this piece go away, if I could get this gone, I would have just y equals a number. Well, unfortunately, you can't just like scribble it out or erase it. What we're going to have to do is, to make this go away, well, 8 minus 8 equals 0. Well, if this piece equals 0, it's gone. I don't need it anymore. So I just have y equals. But if you subtract 8 on one side of your equal sign, you also have to subtract 8 on the other. And so here we have 5 minus 8 gives us negative 3. So I think this is the solution to our equation. Now the directions also say be sure to check your answer. So let's check it. If I have 8 plus negative 3 equals 5, I plugged in what I think the solution is in for the y. So 8 plus negative 3 is 5. And you can check it with a calculator if you want to. I have a calculator here. So 8 plus 3 negative equals 5. So this does work out. This is true. That means that this negative 3 is the solution to this equation. So the goal is you're always going to do the opposite of what's happening to the variable. My letter B. So I draw my line down to separate my two sides. This is my variable, and my variable is being multiplied by 12. The opposite of being multiplied would be to divide. So if I divide both sides by 12, my variable will be by itself. Because watch this. 12 divided by 12, just dividing the number part. 12 divided by 12 is 1. And we could say 36 divided by 12 is 3. But having a 1 in front of the variable doesn't change anything. I mean, this 1m equals 3. Well, over here, I have 1y equals negative 3. So having a 1 in front of the variable is allowed. And it's actually kind of not even needed. I'm fine if I just go like this and go boom, no more 1. That 1 in front of the variable, it's called the coefficient of the variable. That coefficient of 1 is always kind of there. I mean, this a right here has a little imaginary 1 in front of it. This p has an imaginary 1. There's 1p, 1a, 1y, 1m. So if you ever have a variable with a variable with no number in front, no coefficient, you can, if you would like to, put a 1 in front. But the reverse is also true. If you have a 1 in front of a variable and you don't want it, you don't need it, you can actually erase that 1. And so we think this is the answer. Let's check. If I take 12 times by, I think the answer is 3, equals 36. Let's check. 12 times 3 equals 36. Well, 12 times 3 is 36. So yes, this is true. That is my answer. Letter C. All right, so there's my two sides. Now this problem's a little different. The variable's on the other side of the equal sign. It doesn't make a difference. We'll still do the same steps. So I'm going to do the opposite of what's happening to the variable. This variable is being subtracted by 8. So the way you get rid of a subtract 8 is you add 8. And the reason why this works is the same reason why it worked up here. Look, I have a positive 8 minus 8 was 0. Here, negative 8 plus 8 is 0. This piece cancels out. So I have p equals. On this side, if I add 8, 5 plus 8 is 13. So I think this is the answer. Let's check. 5 hopefully equals 13 minus 8. 13 minus 8 is 5, so yes, this worked out. That is the solution to my problem. P equals 13. All right, letter D. Draw a line, separate by two sides. My variable, is being divided by 4. So the opposite of dividing by 4, the opposite of division, is multiplication. So if I would multiply both sides by 4, let's see, times by 4, times by 4. These 4s cancel the same way that these 12s canceled. Because I'd have a 4a up top and a 4 down below. So this 4 and this 4 can divide, give me 1a, and that gives me a negative 64. And if you remember, having this extra 1 in front of the variable, it's not needed. It's just there for show. So 1a is the same thing as a equals negative 64. And let's check our work. If we take negative 64 divided by 4, hopefully we get negative 16. Well, let's have the calculator help us. 64 negative divided by 4 equals negative 16. So that worked out. So these are all one-step equations. The equations you're going to see are going to be similar. Go ahead, pause the video, try these 4 problems on your own, and when you're ready to continue, hit play, and we'll go through them together. All right, so let's see how you did. E, F, G, H. I'm going to start by drawing my line. My variable is being added by 3, so if I subtract 3 on both sides, this cancels out. M equals, this gives me negative 6. To check my answer, negative 3 equals negative 6 plus 3. I plugged in what I think the solution is in for the variable. Negative 6 plus 3 is negative 3. I know this off the top of my head, but you could also check using a calculator. This works. Letter F. Let's see, my variable is being divided by negative 2. So the opposite of dividing by negative 2 is to multiply by negative 2 on both sides. Always do everything on both sides because we're trying to keep these equations balanced. If you do something to one side of the equation, do the same thing to the other. Let's see, over here, a multiply by negative 2 and a divide by negative 2 will cancel because, again, negative 2 divided by negative 2 is equal to 1r, and that 1 is not necessarily needed. On the other side, 5 times negative 2 is negative 10. Okay, let's check our answer. Negative 10 divided by 2 hopefully equals, oopsie, it's a negative 2, hopefully equals 5. And if you check with your calculator, it works. Negative 10 divided by negative 2 is equal to 5. Letter G. Let's see. My variable is being added by negative 3. These are some of the problems that cause some confusion for some students. And I don't know if it's just the way I explain it or not, but here's what I would do to solve this problem. You can check to see if you did the right thing. What I would do to get rid of this negative 3 is I'm actually going to add 3. And you're going to say, wait. The variable is being added by negative 3, so shouldn't I subtract a negative 3? And the answer is, yeah, you could. If you actually do minus negative 3, do you know what a minus a negative 3 really means? It means plus. If you had 5 minus negative 3, keep, flip, change, you get 8. So if you minus a negative 3, you actually get a plus. The way I think about it, though, I honestly don't think about these as adding and subtracting. To me, this 3, it's negative. The way you get rid of a negative, the positive. That term will cancel out. On the other side, if you add 3, W equals 12. Let's see, the check would be negative 3 plus 12 equals 9, and negative 3 plus 12 does equal 9. It takes a lot of practice to get used to the whole negative subtraction thing, but it comes with practice. You'll get it over time. If it's not making a lot of sense now, the more problems you do, the better you'll be able to make those connections for yourself and understand the rules a little bit better. Letter H. My variable is being subtracted by 6. So we add 6. The way I think about it, this 6 is negative. I use a positive. See? Negative 6, positive 6. Negative 3, positive 3. Positive 3, negative 3. Here, we actually use the same sign because this is a division. With the division and the multiplication, you do want to use the same sign. These cancel. U equals 6. Here are 4 more. I think these are the last 4 of this type. So what I'd like you to do, pause the video, try them on your own. When you're ready to continue, hit play, and we'll go through them together. Okay, so let's see. Draw our line. My variable is being subtracted by 4, so if I add 4, or if you can think about it as a negative 4 and positive 4, t equals 1. And check it out. Let's see. 1 minus 4 might equal negative 3. And if you check with a calculator, this math does work out. 1 minus 4 is negative 3. Yes, that is the solution to the problem. T equals 1. Letter J. Let's see. My variable is being multiplied by 7. So if I divide by 7 on both sides, these cancel. Now don't remember, they don't actually cancel to 0. It equals 1h. And that 1 is not needed, so we can write just h. On the other side, 28 divided by 7 is 4. And check. 28 equals 7 times by 4. Plugging that in for h. And that's 28 equals 28. It works. Letter K. Oopsie, that's not a very good line. There we go. My variable is being divided by negative 7. So if I multiply both sides by negative 7, and the reason why, I guess, I mentioned that on the last page about the signs being the same when you multiply and divide, the reason is because in this case, you want those negatives to cancel. A negative divided by a negative is a positive. So when I take a negative 7 divided by negative 7, they both cancel to give me a positive 1g, and that 1 is not needed. Over here, negative 7 times by negative 14. I don't know all that off the top of my head, so let's see. 7 negative times by 14 negative equals 98. Well, let's see if we're right. Negative 14 equals 98 divided by negative 7. Mr. Calculator says 98 divided by negative 7 equals negative 14. It works out. letter L. Let's see, my variable is being times by, multiplied by a -2. So if you divide by -2, the negatives cancel, the 2's cancel, I get Q equals, remember, it is actually a 1Q, but I don't write the 1. Q equals 3. -6 divided by -2 is 3. Let's check. -2 times by 3 equals -6. And yes, this works. -2 times by 3 is -6. So that is my solution. Now, the next example we have here is, now you see we have the same kind of one-step equations, but we have these ugly fractions. Most people despise having fractions, but you'll see they're really not that bad to solve. So this rational coefficient, this fractional number in front of the variable, can be got rid of fairly easily. So first off, there's two ways to think about this. One way to think about this is, you could say, well, this says -2/7 times by x. So the way we got rid of these before is you do the opposite. So if this is a multiply, you would divide by -2/7 on both sides, and you get your answer. And this would absolutely work out. If you have a calculator that can do fractions, it's simple. You just type in 4 divided by -2/7, and it would give you your answer. But without a calculator, this is a little cumbersome. Dividing fractions, if you don't remember how to do it, it's easy. And the way we do this is, the way we divide fractions is we flip the second fraction and multiply. So if I had, say, 2/7 divided by 2/7, you flip the second fraction. It's called the reciprocal. You flip the second one and you multiply. Because what happens here is 2 times 7 is 14, 7 times 2 is 14, and they cancel down, reduce down to 1. And that's exactly what we want. We want to have a 1 in front of our x. So if I multiply both sides by the reciprocal, my fraction cancels. So if I multiply by -7/2, this whole thing here reduces down to 1. Again, 7 times 2 is 14. 2 times 7 is 14. 14/14 equals 1x. On the other side, when you multiply fractions, you still multiply across the top and across the bottom. So 14 times by -7 is -28. 1 times 2 is 2, which gives me an answer of -14. We multiplied both sides by the reciprocal of the fraction so that the fraction will cancel. It'll give us 1. Let's check our answer. If I have -2/7 times by -14, hopefully that answer equals 4. Let's see. Turn this into a fraction. On the top, -2 times by -14 is a positive 28. 7 times by 1 is 7 equals 4. And yep, 28 divided by 7 is 4. This works out. Now, to show you what I mean about if you have a calculator that can do fractions, all you really have to do is type it in. Watch. I'm going to type in on my calculator 2/7 negative. So there's my -2/7. I'm going to divide by the same thing. 2/7 negative equals, and simplify. Okay, it's not simplifying very well. It does equal 1. Calculator's being not too intelligent. It does equal 1. On the other side, if you would multiply, or I'm sorry, take 4 divided by 2/7 negative equals, and simplify. Simplify. Again, the calculator's not being too intelligent with it, but that does equal a negative 14. So the calculator, if you would take and divide by negative 2/7 on both sides, you get the same answer. Let's see here. We could divide by 1/5 on both sides. We would get our answer. Without a calculator, the process is to multiply both sides by the reciprocal of the fraction. So if I multiply by 5/1, what happens is the tops equal 5, the bottoms equal 5, and 5 divided by 5 is 1k, or just k. So these cancel. On the other side, 5 times 5 is 25, over 1 is still just 25. And to check your work, 1/5 times by 25 equals 5. 1/5 times by 25 equals 5. Yeah, it's being stupid. But it works. It's true. What I'd like you to do is like you to try these two problems, please. Letters C and D. Pause the video, try them on your own. When you're ready to continue, hit play, and we'll go through them together. Okay, so let's see. I'm going to multiply both sides by the reciprocal of the fraction. These cancel because I get 12 over 12, which equals 1m. On this side, multiply the tops gives me negative 24. Multiply the bottom gives me 3. And simplify is negative 8. Okay, let's check our work. Move this over. All right, so check our work. If we have 3/4 of 8 equals negative 6. Oopsie, it should be a negative 8. Let's see, 3/4 as a decimal is 0.75. So 0.75 times by negative 8 equals negative 6. It worked out. Check. We're good. Letter D. The variable is being multiplied by this 1/3. You could divide by 1/3 if you have a calculator that can do that. Or the routine is to flip the second one, multiply by the reciprocal. Multiply both sides by 3/1. You get 3/3, which equals 1y. On the other side, you get 3/5. And to check our math, let's see, 1/3 times by 3/5 equals 1/5. Let's see, this math gives me 3/15. And if you would simplify 3/15, you do get 1/5. So this checks out. That is the correct answer. So here we have some applications. It says, yesterday a cow was milked. Today the cow gave 4.4 gallons of milk, which is 0.9 gallons more than yesterday. Write an equation to model a scenario. Then how much milk was given yesterday? So let's see. It says today it gave 4.4 gallons of milk, which this amount is 0.9 bigger than yesterday. So if we take yesterday's amount and we add 0.9 to it, that would give us today's amount. And this yesterday, does it say anywhere in the problem how much it gave yesterday? No. In fact, that's the thing we're trying to find. So yesterday would be like our variable. How much milk was given yesterday? I don't know. Let's use y. So this is our verbal model. It's kind of a summary of what the problem says. This is our equation. So that's the first part of the problem. Write an equation to model a scenario. Check. Now if we solve this equation, that will give us how much milk was given yesterday. So let's do that. So my variable is being added by 0.9. So if I subtract 0.9, y equals, see, 4.4 minus 0.9. 4.4 minus 0.9 equals 3.5. So yesterday, the cow gave 3.5 gallons of milk. Not too bad of a problem. Letter B. In a small garden, a farmer has 12 rows of corn. In the whole garden, there are 96 stalks of corn. Write an equation to model the scenario. How many stalks of corn are in each row? Okay, so let's see. I'm imagining we've got our cornfield here, and it says there's 12 rows. So rows go this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 rows of corn that go across this way. And there's a total of 96 corn stalks. So, well, to figure out how many, if there's like the same number of corn in each row, that would mean that if you take the number of rows times by how many are in each row, that would give you a total. It's kind of like finding area of something. So if you had a rectangle that was 3 units this way and 5 units this way, if you multiply the length times the width, the rows times the column, or how many are in each row, that would give you a total of 15. That's essentially what this is saying. It's saying there's 12 rows here, there's a total of 96. How many are in each row? Let's see. This is our verbal model. There are 12 rows times by the thing we don't know. So let's call it X or C for corn. I like that. Equals the total. And the total, it says, is 96. So that is our equation. Now, if we solve our equation, that will tell us how many stalks of corn are in each row. So I take my variables being multiplied by 12. So if I divide by 12, I get C equals 96 divided by 12 is 8, I believe. 96 divided by 12 is 8. Good. So there would be 8 stalks of corn in each row. 12 rows, 8 in each row gives us a total of 96. So that is our solution. I have 2 for you to try. Here's letter C. It says, a board was cut into 4 pieces. Each piece is 7 inches long. Write an equation to model the scenario. How long was the original board? Go ahead, pause the video, do it on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, so I imagine you got your board here, which we don't know how long it is originally. So the length of this is my unknown thing. So maybe I'll use B for board. But I know it was cut into 4 pieces. Boom, boom, boom. Each piece is 7 inches. Now, that in alone, right there, I could find out the length of the original board. Just from my little picture here, I got my answer. I know the answer is going to be 28 inches. 7 plus 7 plus 7 plus 7 gives me 28. But that's not what the question wants. I mean, yes, it wants the answer, but it also wants us to write an equation to model this. So here's how I think about this. If I have my board, and if you're cutting something up into pieces, that is division. If you take a pizza and you cut it into, you cut it like this way, you divided it by 2. Now you've divided it by 4. You're cutting it up into pieces. You're dividing it into smaller and smaller pieces. So my board, I divided into 4 pieces. And the result of that, after I took my board and divided it into 4 pieces, I got pieces that were 7 inches long. And this would be my verbal model. Now, to get the equation, we just substitute the word board for the b. So b divided by 4 equals 7. So there's our equation. And the solution, well, if you multiply both sides by 4, these cancel. B equals 28. And that's what we said we should get when we did our little picture over here off to the side. So the board was originally 28 inches long. And this is the solution. All right, last problem for the day. It says a factory produced many light bulbs yesterday. The factory then sold 3,457 light bulbs. And now they have 2,872 light bulbs. Write and solve an equation to find how many light bulbs the factory produced yesterday. Go ahead, pause the video, make yourself a verbal model, write out your equation, solve your equation, find your answer. When you're ready to continue, hit play. We'll go through it together. All right, so here's my verbal model. I've got the bulbs they made yesterday. So they made all these light bulbs yesterday, which I don't know how big that is. That's the thing we're trying to find. How many light bulbs did they produce yesterday? I don't know. So B for bulbs. So if all these bulbs, but then you sell a bunch, you get rid of a bunch, you sell, 3,457 of them. And that gives you 2,872 left. Well, yesterday's bulbs minus what you sold equals how many there are left. That would be the verbal model. And the letters and numbers here would actually be the equation. I'm going to pretty it up, but essentially it's B minus 3,457 equals 2,872. That is your equation. And to solve this equation, since this is a subtraction, the variable's minus that. If you add 3,457 to both sides, these cancel out, and B equals, let's do the math up here. So we got 9 and 12, carry the 1. 12 plus 1 is 13, carry the 1. 3 plus 2 is 5, plus 1 is 6. So I think the answer is they had 6,329 bulbs yesterday. Now I'm going to check using the calculator. So I'm going to take 6,329 bulbs minus 3,457 bulbs they sold, and we should get 2,872. Math checks out. We got it. That is how many bulbs they had yesterday. All right, so for our summary, type 1, got 3 minutes on the clock, which is a bit longer than normal. It says here, oopsie. Now that you've learned about solving these one-step equations, give a brief summary about what you learned. Or maybe if you already know it and you didn't learn anything new, give a brief summary about what the lesson is about, maybe give a brief summary about some of the tips that you would explain to somebody else on how to solve these problems, little things like that. So go ahead, take 3 minutes, pause the video. This has been lesson 4.1. Thanks for watching.